my name is Miss Connolly. I started making videos for my 5th grade students and decided I wanted to make videos for all students to learn, so here we are. If you have a topic you want me to cover, connollymathathome@gmail.com, and I'll get a video back to you as soon as I can, grades 1 through 5 math content. And today we're going to talk about comparing fractions. So we've covered several different conjectures on this channel. So we have talked about comparing fractions to a whole, comparing fractions to a half, comparing fractions when we have the same numerator, comparing fractions when we have the same denominator. And today we're going to talk about another situation because we have two fractions here, 5/6 and 7/8. Okay? They have different numerators, different denominators. They're both less than one whole and they're both greater than one half. But they have something else in common that's going to help us think about how to compare them. And you have to be looking for these things when you're comparing fractions. You need to know the conjectures so that you can say, which one do I use in this situation? Okay, so in comparing to a half, you might notice one's greater than a half and one's less than a half. That's when you use that conjecture. But when you can't use that one, you have to rely on another one. So let's think about what's going on with these two fractions. So we have 5/6 and we have 7/8. I've represented both of them on an area model and both on a number line. And when you look at my area model especially, it is very difficult to tell for sure, 100% positive say which fraction is greater. It's really hard to accurately draw eighths. It's hard to accurately draw sixths. And it almost looks like they're the same size. Okay, on the number line, one of them looks slightly larger, but again, I can't say for sure from looking at my representation because I knew I drew it, I didn't use a ruler, I don't know. I don't know for sure which one's bigger. So I'm going to think about what do these fractions have in common. And they do have something in common. Even though they don't have the same numerator, they don't have the same denominator, they are both less than a whole, they are both greater than a half. There's another thing I want us to look at, and it's this piece right here. Both of these fractions are one piece from a whole. When we have two fractions that are one piece from a whole, there is something that we can consider to determine which one is greater. And just so you know, you can also compare when two fractions are one piece from a half, but for this video, I'm going to do just one piece from a whole so that we can learn it that way. So, what do we know about these pieces that are one piece from a whole? Well, I know that this representation has to deal with eighths, and this representation here is dealing with sixths. So I want to think to myself about the size of the pieces, okay? I'm going to come back to 5/6 and 7/8 at the end because they are so close, so I need us to think about that. I'm going to use two fractions that are they're a little different in size so we can clearly see what's going on, okay? So we're going to come back to this at the end. I just wanted you to see that sometimes we can't rely on those representations because they are so close in size. So let's take a look at some other fractions that are both, we're still going to be thinking about one piece from a whole. So 6/6 is a whole, I only have 5/6, I'm missing one piece. 7/8 is one piece from a whole, I'm missing just this one piece here, okay? All right, so let's look at two other fractions that are both one piece from a whole, but that we can kind of make some generalizations about. So let's think about 2/3. So I can represent 2/3 by drawing 3 equal parts and shading 2 in. And then I'm going to think about that 7/8 again. And as you know, when we're comparing fractions, we want to think about the same size whole, the best that we can, and draw equal parts the best that we can. And I'm going to shade in 7/8. So, both of these fractions are one piece from a whole. Okay? What we need to think about right now is the piece that's left over. Okay? So, in red, I'm going to shade in the piece that is left over. Okay? So, 1/3 is left to make the whole, and 1/8 is left to make the whole down here. And what we want to be thinking about is which one has a smaller piece left over, because that means that we've gotten closer to a whole. Okay, let me show it on the number line in case that's a way that supports your understanding. Okay, so if I put 2/3 on the number line, and then I make the same size hole underneath and show eighths, always the same size hole when we're comparing. Let me get down here. All right, 4/8. When we're doing this on the number line, we're always partitioning into the correct number of equal parts. So, we're going to be talking about this piece left over here, and then this piece, whoa, way off, that's left over here. Made my thirds not equal pieces. Okay, so in both situations, we want to be thinking about the distance from one whole, which is a little bit different because usually we think about the distance from 0 when we're thinking about the size, and you can clearly see it here, 7/8 and 2/3. You can see that 7/8 is a greater distance from 0, but for these situations, we want to think about which one is closer to one whole. Okay, so when we look at the piece that's left over here and the piece that's left over here, they're clearly different sizes. So here's how it's going to go. Let's think about the size of the pieces with the denominator, okay? So when we're thinking about thirds, we're sharing with less people, so our pieces are bigger. And you see this third, the pieces is bigger, right? When we're thinking about eighths, and we're sharing with 8 people, if this was a pizza, for example, this piece that's left over is much smaller. So that means more of the pizza has gotten eaten if we're talking about 7/8, because the piece left over is smaller. So when we have a smaller denominator, bigger pieces, bigger denominator, smaller pieces, it's confusing to think about, but think about how many people you're sharing with. And when we end up with that smaller piece left over, we're closer to having the whole thing shaded in. Okay, we're closer to a whole over here when we have a smaller piece left over. Will this always be true? Will it always be true that when our denominator is greater, that we're going to have a smaller piece left over? Is it always true that when our denominator is greater, the pieces are smaller? Is it always true that when our denominator is smaller, the pieces are bigger? We're going to take a look at another one and see. But for now, I want us thinking about which one is greater. So we see 7/8 is clearly greater, so I'm just going to brainstorm a couple of these up here. Okay, so we see that 7/8 is greater than 2/3. They're both one piece from a whole. And right now what we're trying to think about is when there are smaller pieces, that small piece left over, are we closer to a whole every single time we have smaller pieces? Let's keep discovering. You got to try a couple to see if it's true. Okay, so let's look at a couple more fractions that are both one piece from a whole. Okay, so this time we'll think about 4/5, and we will think about 9/10. So we want to be thinking about, I'm just going to do the area models just to save time. We want to be thinking about which one of these is closer to a whole. They're both missing one piece to get to a whole, but I need you to think about which one has the smaller piece left over, which means that more of the pizza has been eaten if we're thinking about it as a pizza. Okay, so think about that as I start to draw these. So I have 5/5, I'm going to shade in 4. Okay, one piece from a whole. Then I'm going to do my very best to split this into 10ths. So halfway would be here. 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to shade in 9/10. Okay, and we're thinking about which one of these is closer to a whole, because which one has the smaller piece left over. Is this piece take us closer to a hole, or does this piece, since it's smaller, bring us closer to a hole? And what I'm noticing is that 9/10, based on our representation, we can tell that it's clearly larger. And we also are thinking about the size of this last piece. 1/10 is a lot smaller than that 1/5 that's left over. Therefore, we've eaten more of that pizza. We've just left 1/10 left to get to a hole. Over here, there's 1/5 left to get to a hole. So instead of comparing the size of these pieces, we're comparing the size that's left over. And the smaller piece that's left over means that more of it has been eaten or more of it's shaded in. So, interesting. So here we have 9/10 is greater than 4/5. Last time, we saw that 7/8 was greater than 2/3. So we're starting to make a generalization about the situation. When my denominator is larger, my pieces are smaller. Then I think about when my denominator is smaller, my pieces are bigger. So then, lots of thinking, then we think about, so what is the size of the piece left over? If I just have 1/10 left over, that's a smaller piece, which means I'm closer to the whole thing being gone, being eaten, closer to the one whole. And then if I have a bigger piece left over, I'm further away from a whole. So we have to think about this. When I have a bigger denominator, I have smaller pieces. So that means the piece left over is smaller. Therefore, I'm closer to one whole. Same thing happened up here. 1/8 were smaller pieces. So we saw, and it was really clear, that little 1/8 that I shaded in red was smaller than what was left over with the 1/3, which means I was closer to a whole with 7/8. Okay, let's look at one more. Then I'll put the conjecture up for you. If you've been watching the conjecture videos, get a notebook ready so you can jot it down. All right. So, I'll use orange. I haven't used orange yet, I don't think, in any videos. All right, so let's think about pieces, the one piece from a whole. 1/2 is one piece from a whole, right? And we can think about comparing that to 3/4. So let's see. Which one has bigger pieces? 1/2 or 3/4? Halves have bigger pieces because the denominator is smaller. So they're both going to have one piece that's not shaded in. Okay? One piece that's not shaded in. I want to think about which one has the smaller piece left over, because that means that I am closer to having eaten. I'm going to refer to it as a pizza because that's the easiest way for me to think about it. Which one has the smaller piece left over? And we clearly see that 4/4 are smaller pieces. The denominator is larger, so I have to split the pizza with more people, and there's smaller pieces for everyone. Since the green space is the smaller piece left over, I'm closer to a whole. So this is different than the other conjectures that we thought about, because now we're thinking about the leftover piece. So, again, what we have going on here is when you have when both fractions are one piece from a whole, they're all one piece from getting to a whole. The fraction with the larger denominator has a smaller piece left over, therefore you're closer to a whole. Okay? So I'm going to put the conjecture up, so in case you wanted to write it down. Then we'll come back to that 5/6 and 7/8. So here it is. When two fractions are both one piece from a whole, the fraction with the greater denominator is greater. So the larger denominator is bigger. Why? Why is this happening? In blue, a greater denominator means smaller pieces. So the leftover piece is smaller, therefore closer to a whole. Okay? So the smaller piece that's left over brings you closer to have eaten the whole thing. It brings you closer to the one on the number line. When you have a larger denominator, so when both fractions are one piece from a whole, the fraction with the greater denominator is larger because the piece left over is smaller. Okay, so let me show, I'll do 1/2 and 3/4 on the number line too, so you can see that piece that's left over that you still have to travel. That's also the number one, I'll put it up here. Then this is a whole 4/4, 3/4, 2/4, 1/4, and 0. Okay, so we're thinking about this piece that's left over. This piece here that's left over, ooh, we almost went down, is closer to a whole. Okay, so you can see since this piece is smaller, my denominator is greater, therefore I make smaller pieces. I'm closer to one whole than I was with 1/2, which has this big long piece left over. Okay, so let's come back to 5, 6, and 7/8. Weird classroom setup right now. 5, 6, and 7/8. And I want you to tell me which one is greater. Well, you can't tell me, but I'm going to be hoping that you're shouting to me over the computer or TV right now. So, 5, 6, and 7/8. They're both one piece from a whole. I know when I drew them, my representation was unclear because they were so close in size. So, I take my conjecture and I think about it. Ooh, darling, having a tough time today. All right, so when two fractions are both one piece from a whole, they're both one piece from a whole, the fraction with the greater denominator is greater. So which one of these has a greater denominator? 7/8. And why is this true? Since 7/8 has a greater denominator, that means the pieces are smaller, which means the last piece, that 1/8 that's left over to make 8/8, is smaller, therefore it's closer to a whole. Because that little piece left over, that white space, is smaller. We're thinking about that leftover piece. Okay? So, I want you to tackle these fraction problems, and I want you using this conjecture to decide which fraction is greater. Okay? So, 7/8 is greater than 5/6. Here's a couple more for you to try at home. I want you thinking about 3/4 compared to 7/8. I want you thinking about 9/10 compared to 11/12. If you were going to represent those, it's going to be too hard to tell, so you have to rely on your conjecture. And finally, drop this one down too. I want you to compare 5/6, and I want you to compare that to, let's think about 99/100ths, because I know you're not going to draw 100 equal pieces, so you have to rely on my conjecture. Okay, so remember, when you have two fractions that are both one piece from a whole, this is the only time you're using it. You can use it when they're both one piece from a half, but we haven't gone over that yet. But anyways, back to what I was saying. When both fractions are one piece from a whole, the one with the greater denominator is greater because the leftover piece is smaller. Okay? Give it a try, practice it a few times. Bye.